academic stars, welcome to Caltex Academy. Today on our board, I'm going to walk you through this chemistry question on empirical formulae. And today, I'm going to make you understand how to get the simplest formula or empirical formula when you're given masses of each of the elements mentioned from the question. So without further ado, let's dive in and take a look at our question. So the question says a compound contains 2.8 grams of copper and 0.7 gram of oxygen. And we're given here the relative atomic mass of copper as 63.5, oxygen equals to 16, and we are asked to determine the simplest formula. In other words, this is empirical formula. And part B is saying what is the percentage composition by mass of copper. Now, when you have a question of this type, what do you do exactly in order for you to work it out without any delay? So the first thing we have to arrange in terms of the elements. Now we know that these two elements are copper and oxygen. Therefore, we can move on and put our element here that is copper. You are free to abbreviate, but for me, I just want to write it in full before abbreviating it as CU. And the next element here is oxygen. So we can place our oxygen here, and its short form is O. Now, after that, the next thing here is to write out the masses, their composition by mass. So we can say mass, and here the mass is given in grams. So for copper, we're given 2.8, and since I put it given the unit here, we don't need to repeat ourselves. And oxygen is 0.7. Now the next thing here we also need to take care of is relative atomic mass. So let me abbreviate this as relative atomic mass, RAM. Then for copper, we have 63.5. And for oxygen, we have 16. So next, we need to get the number of moles. And number of moles is given by the mass over relative atomic mass. We can write here number of moles. Here we have 2.8 dividing 63.5. Number of moles of oxygen is 0.7 divided by 16. So let's get our calculator and input 2.8 by 63.5. The result is 0.044 to 3 decimal places. So let's get some space and give our solution there. This is 0.044. And let's do the same to the next element here, that is oxygen. So we have 0.7 divided by 16, and our result is 0.04375. We can also round to 3 decimal places to 44. So we have here 0.044. And since they're the same number of moles, then this one will vanish down to 1. Where is that 1 coming from? So let me show you an extra step, which if you're already expert, you can decide to ignore. So we normally say divide by the smallest ratio. Now here, they're the same, so we divide by itself 0.044. Also 0.044. We divide by 0.044, and therefore each one of them goes to 1 is to 1. So what I've written here is a ratio, so we can say mole ratio. Why do I call it mole ratio? Because it comes from number of moles. So since it's 1 is to 1, then we can go on and take a look at our element we have listed up here. So we bring them together to form a compound. The simplest ratio that is answering our first part of the question, that is A, is copper 2 oxide. And our first part of the question is done. Now the next part of the question is asking us to also determine the percentage composition of copper. So we have seen here that the mass of copper is 2.8. Now before that, we need to first get the total mass used for this compound here. And if copper is having a mass of 2.8 and we have oxygen has a mass of 0.7, then we need to get its total So the total here is adding all this together. This is 15, right? 5, you carry 1, and then 1 plus 2 is 3. Therefore, the total mass here is 3.8. To answer part B of the question, we say percentage composition of copper is now given by mass of copper over mass of copper to oxide term is 100%. So let's make substitution here, and we have 2.8 over 3.5, and we multiply this by 100%. Now we can reduce down a little before maybe putting it in the calculator. Like when we multiply 2.8 by 100, it will reduce down to 280, and we're dividing this by 3.5. Now let us go on and divide this from our calc. So we have 280 dividing 3.5. Our result is 80. Therefore, the percentage composition by mass of copper is 80%. So the remaining 20 is for oxygen. And that is it for this question. If I've watched at this time and I've gotten some value from this video, please consider subscribing to the channel so that you'll also get notified. In our next video, we're going to discuss about also calculating empirical formula from given percentage compositions of each individual element. So you don't need to miss out from that beautiful lesson. So see you in that video. Peace out.